at the components of UML use case diagrams, and we talked about the rectangle representing a square, a system. We talked about the oval representing a use case, and we said in this case the use case is a functionality of the system and is normally represented using verbs. Then we talked about actors, and we say an actor can be a person or an entity that takes part or takes up a role in that particular system. We talked about relationships, and we say we show them using arrows. Okay, so we looked at this example, this entire system, and I also talked about this box. Yeah, just a recap of what we actually looked at. So I want us to move to, it just looks at some use case examples, and the first example that we're going to look at under the use case is this one that has what we call association link. Yeah, we have this one that has association link. So a use case diagram that is showing some use cases where the actor here, we have the actor who is a student, and then we have books. So this type of a link that you see here, we call it association link. So in other words, the books are associated with the student. A student can borrow a book. So this type of a relationship that is shown by this type of an arrow here is an association link. Then we have another example here. Now this one has the include relationship. It has the include relationship. I want to see how we show the include relationship. First of all, we show the include relationship using broken arrows. As you can see, this arrow is broken. It's not a complete line. It's broken. If you look at these ones, so you're going to realize that they are broken arrows. Okay. So we normally use this type of a relationship to include maybe a common behavior from maybe an included use case into a base use case, so that we can have what we call or we can support the reuse of that common behavior. Like for instance, we have borrow books here, so we can check the reserved book. We can also check the fine. So you can see we have that included relationship. Another example here is when we have an extended relationship. This is how we represent an extended relationship. Request a book, then we have extension points. We have this showing extended. So we have another type of a relationship. We call it generalization relationship. Now, in a generalization relationship, what it means is that we have a child use case that is actually going to take up or inherit the behavior and actually the meaning of the parent use case. So we have a child use case, then we have the parent use case. So when we have the child use case, might add or might have the parent behavior or might override the parent behavior. So we have this figure here that I'm showing you as an example that has actually two generalization connectors that connect between three use cases. So if you look at it, you have a search by call number as a child, and we have search by author as a child also. But all these are child cases of this parent case. So if you want to show child cases of parent case, this is how we show them. Now it means we can do two types of searches. So again, searching a book by the call number, searching a book by the author of the book, all these are children of this parent case here. So if you want to show children to a parent case, this is how we show it. So assuming we had a third one, assuming we just had a third one, maybe we are able to search by date, then we would have something like, we can add another one here, there, and then we have this one, and we say search by date. So that's how we show a parent use case and the child use cases and how they are actually related to. So that is the example that I'm showing you. So we have another one here, just a vehicle sales system example. Yeah, so this is a complete use case for a vehicle sales system. Yes. Now, if you look at it, you see that all these use cases, just like we said previously, that the use cases are functions, and we before we even talk about the use cases, I said we have the system boundary that is normally shown by a rectangle. So this is the system boundary. As you can see, this one is the system boundary, normally shown using a rectangle. Then we have the use cases. So we have the various use cases here. This is the first one, this is the second one. You have the third, fourth, fifth, sixth, seventh, eighth, ninth. So these are use cases. Um, Then we have the actors, and we say the actors are either a person or of an entity that takes up a role in that particular system. So we have this actor, we have this other 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 actor. So as you can see, you can represent a complete system using a use case diagram. And most of the questions in ABMA, this is what they are going to ask you. They are going to tell you to draw maybe the UML use case diagram for maybe a booking system or a hotel reservation system, or etc, etc, etc. They're not going to stick to one particular system. So what you are required is to understand what components are there, understand what relationships are there. So when you are drawing, you can actually show the components and the relationships. So when you look at this vehicle sales system, you can see the first thing that we have here is make payment arrangements. Then make payment arrangements extends to the functionality of making offer. We have extension points here that is actually make payments arrangements. So you can see we have update customer information that is normally extended to the old customer offer, and we have a child and parent relationship here, as you can see. So we have this old customer, transferring it to the make old customer offer here. So this customer is actually able to access this offer, and then the customer can actually make an offer here. Then we have a new customer. This is a new customer. The new customer can come here, make new customer offer. Then you can create the new customer here. In this is a function to create the new customer. Again, all these, the new customer and the old customer, are parent of this. They are child of the customer. They are child of the customer. So these are child entities of this customer here. So again, we have the management. The management can accept the offer. As you can see, the management here can accept the offer. So is going to manage offers. Then we have the salesperson supplying the records. We have the records of sales contract, and is included to this. Now, if you look at this thing, you can actually put an entire system. You can actually draw an entire system using the UML use case diagrams. So it's a place that it's something that you need actually to master. You need to master. Now let's look at how do we draw a use case diagram. How do we draw a use case diagram? So there are a number of things that we need to we should identify. There are a number of things that we should identify when we want to draw use case diagrams. And the first one is the functionalities that are supposed to be represented in the use case. What are the functionalities of that system that you are supposed to represent in the use case diagram that you want to draw? So identify those functionalities. If it is a booking system, identify all the functionalities that are in that particular system and that are supposed to be shown in are supposed to be shown in the use case diagram. Okay, that's good. Then you need to identify also the actors. Who are the actors of the system? Because basically, in terms of actors, we are talking about the people or entities that are going to take roles in that particular system. So identify the functionalities, then identify the actors of that particular system. Then again, more importantly, identify the relationship. So what is the relationship among the use cases that you have and the actors? Remember, these use cases are the functionalities that you identified here. So what relationship is there between the actor and the use cases, or the use case and the actor? Those are three things that you need to identify even before you move on and you think of how to actually update whatever that is there. Okay, just a moment. Right, let's go on. So one important thing that you need to know is that we are drawing use case diagrams so that we are able to capture the functional requirements of a particular system. So we need to identify all those three items that I have mentioned there: the functionalities, the actors, and the relationships. Then once we are done, we can use the following guidelines here that I am taking you through to draw. And the first guideline that I am talking about is actually we have the name of a use case. The name of a use case is very important. So you need to choose the name of a use case in a way that it is going to identify what function it is going to play. Because you are going to show those functions that we identified using use cases. So the name that you give to that use case should be descriptive enough to actually identify what function is being performed by that particular use case. Then number two, the name that you give the actors must be suitable. You don't just give names. Make sure you are giving the name to an actor that is actually showing the right description of that particular role that is going to be taken care of in that entire system. Number three, you are supposed to show the relationships and all the dependencies are supposed to be shown on the diagram. In the diagram, we need to see the relationship, we need to see the dependencies. Now, number four, which is actually something like a warning, I would say you should not try to include all the types of relationships, because the main purpose of this diagram is to make sure that we are identifying the requirements. Okay, it is also important to make sure that you're going to use notes whenever it is required to provide more clarity. Then you make sure you're using some notes to note some important points. That is important to also know. So if you look down here, I'm just showing you a sample of a use case diagram that is actually showing the order management system. So if you're going to look into this particular diagram, then you're going to see three use cases. We have the order, the special order, and we have the normal order. So we have one actor who is actually the customer. Okay. Now, when you look at just from our own thinking, yeah, the special order and the normal order are actually childs of the order. So that means they are extended from. They are extended from the order use case. So we need to show them using extended relationship. That is one very important thing to note. We have order, then under order we have the special order, then we have the normal order. So that means the special order and the normal order are children of the order use case, the order use case. So that means we need to show them using an extended relationship. Another important point is to make sure that we are identifying the system boundary. Okay, and the system boundary we said is actually that shown by a rectangle. And normally we said we have the actor is supposed to lie outside the system boundary. So if you look at this example, so you can see here a use case diagram of an order management system. So we have the actor here, and the actor, we have labeled the actor as customer. Remember we said you need appropriate or suitable names even for actors. So we have the order. I want you to see a very important thing here. The first thing we said is that we have the order, and this order is actually the parent of the two types of orders, which is the special order here and also the normal order. So we need to show using an extended relationship. Now you can see we have shown using dots here. Yeah. So we show using an extended relationship. Now what we are trying to say is that the normal order and the special order are children of the order, the use case order. So we have shown that. Then we have shown our boundary here. We have our system boundary. Of course, we said we use a rectangle. We said we use a rectangle. We have our system boundary that is seen here. Now, this is just a single or a simple uh, use case diagram that contains only one actor, and it has three functionalities: the order, special order, and normal order. And we have identified the relationship that we have the order as a parent use case, but we have children use cases, which are the special order and the normal order. So we are showing them using extended. That is one thing that we really need to note. Now, it is important to also understand where exactly do we use case diagrams? Where do we use cases diagrams? So use cases diagrams can be used in various applications. And the first one is in requirements analysis and high level design. So we can use case diagrams when we are doing requirements analysis and when we are engaging high level design. Then we can also use cases to model the context of a system. It is also used in what we call reverse engineering. It is also used in forward engineering. Okay, now I've talked about this, what actually the use case diagrams depict, and we say they depict use cases, and we say the use cases are actually the actions or the functions of a system, and they are normally done by an actor. Then we have the actors, and we say the actor is a person. It can be a person, an organization, or an external system, or just an entity that is actually playing either one role or even more roles in interacting with that particular system. And we said they're normally drawn using ovals. Or some other books call it stick figures. Then we have associations. Associations are normally shown between the actor, uh-huh, and they're normally shown using solid lines. So we are showing solid lines, except when we have extended associations. That's when we show with broken lines. So then the system boundary which is optional, but for me, I'm going to tell you it is a must. For the purposes of exams, make sure you draw that rectangle box, which is the system boundaries. You have the use cases inside the system boundary, and you have the actors outside the boundary. That is very important. So these are other use case diagrams, other examples that you can just look at and see how use case diagrams actually are. So if you look at this, for example, we have a customer. The customer is able to search for items. The customer is able to place an order. The customer is able to obtain help. So when you place an order, then we have the payment processor as this is another a subsystem, but is now acting as an actor. So the order that the customer places goes to the payment processor. Now you can see we've shown the payment process as an actor, as much as it is a system, but it is playing a role in this particular system. So that is why we've shown that as an actor. Again, when it comes to the customer obtaining help, now this use case is actually a function that is provided by the customer support as maybe officer or agent or employee. So that is why now we have this person here and an arrow linking here. Again, we have the time. So here we have submitting taxes, then we have a tax authority. You're not just submitting taxes to nobody. So the tax authority is also taking a role in when it comes to the submission of taxes here. So it is important to make sure that you understand things. Now, again, I want you to see one thing, that we have another rectangular box here. Let me just clear this off so that I show you what I'm talking about. We have this big rectangular box. Let me just change the color. We have this big rectangular box here. This one. This is a system. We see inside it we have a subsystem. Now you can see this one. This is a subsystem. This is another rectangular box. And inside of it, it has the search for items and place order. That is a subsystem. Then we have another subsystem here that is actually dealing with taxes. That is there. We have the tax agent. So always notice that we are using the rectangle to show subsystem. So we have we can apply packages to simplify use cases, as you can see here. But I don't want to really go into the details of this because the ABMA does not put much focus into that. Yes, so that's about use case diagram. Now the other thing that we can look at is analyzing the requirements of information systems. This is something that we looked at it in details. What is the meaning of requirements analysis? Now, requirements analysis is actually a process that we use to define what the user expects from an application that is supposed to be built. We use it to define users' expectations from an application that is going to be built, or an application that needs to be modified. We have an existing application, but we need to modify it. So that process of actually looking at what are the requirements of this particular user about what are the expectations of this particular user about that particular system, then that is what we call a requirements analysis. That is what we call requirements analysis. So requirements analysis is going to focus on the various tasks that are actually needed, or conditions that are actually needed to meet, or maybe alter a product, or maybe a project, or creating a new system at all. Yeah, so we talked about uh, different issues concerning requirements. So we need to focus on what are the activities that are actually included when it comes to requirements analysis. So there are 3 activities that are included in requirements analysis. And the first activity is eliciting requirements. Now, eliciting requirements simply means here we are going to define the project. We are going to look at the business process documentation, and also we're going to hold some stakeholder interviews. Now, at times, this particular activity is known as requirements gathering, or in other words, requirement discovery. So when we go out and do interviews to stakeholders and users to actually gather requirements, then we say we are doing requirement gathering, or we are actually discovering the requirements. This is an activity also known as eliciting requirements. Then after we have gathered the requirements, we need to come and analyze the requirements. So we go to the next activity, which is analyzing requirements. And this is actually a process of trying to look at the stated requirements, if they are actually clear, if the requirements are complete, if the requirements are consistent, if the requirements are unambiguous, and if there is any apparel conflict existing in those requirements, we resolve that conflict. So that is in analyzing requirements. So the third one is recording requirements. After we have analyzed the requirements, then we can document those requirements in some various forms, ranging from summary lists, or we can have natural language documents, we can have use cases, we can have user stories, we can have process specifications, and many, many other types of documents. So those are the three activities that are taking place in requirements analysis process. So when you're required to describe the requirements analysis process, I'm actually expecting you to describe these three activities so well. The fourth activity that I will add there is the reviewing and retrospective. The reviewing and retrospective is a step that we normally conduct to look at those requirements to see if they need to be improved or they are okay, so that we have them, we continue with them going forward. So a total of 4 steps for the requirements analysis process. And the first one is eliciting requirements, where I said it is a process where we are gathering the requirements. We communicate with customers or we communicate with stakeholders to understand what are their expectations concerning the system that we are about to build. Then we sit down and look at those requirements to make sure they are complete, to make sure they are consistent, to make sure they are not ambiguous. Um, uh, then we proceed to the third step, where we're going to do the requirements modeling. Just a moment, I take up this phone. Yes, hello. Hey, hey, how are you? Yeah, I'm in class. Can I call you later? So we move to requirements modeling. Sorry for that. In requirements modeling, we are going to document, to make sure that we are actually documenting those requirements in different format. I've mentioned a number of them. Then we go to the review and perspective, where we're just reflecting on the previous requirements gathering techniques to make sure that we are making any improvements that is actually required. So that is the requirements process, a very simple process to remember, a very simple process to explain. So we have techniques that are actually used in analyzing requirements, because we said we have requirements analysis. So we have different techniques that we use to analyze these requirements. And the first technique, we call it business process modeling notation, BPMN, a technique that is normally uh, 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 looked as being similar to creating flowcharts. Yeah, but the BPM and MN, the business process modeling notation, has its own symbols. It has its own elements. So it doesn't use the same symbols and elements that as ones that are used in flowcharts. We're going to look at flowcharts much later, so don't worry about that. Yeah. So we normally use this particular technique to create maybe graphs for the business processes, and then we use those graphs to try to understand the business process. So it is actually a widely used process, or a methodology that is highly improved. Now, the second one is the one that we actually talked about there, the unified modeling language. I've talked about it and I've looked at the use case diagrams using the UML. So it is actually a language that has some set of diagrams that are created to make sure that we are specifying, we are visualizing, and we are creating, even documenting the artifacts of our software system. So it is actually a technique that is very, very useful when it comes to creating object-oriented softwares and even working with the software development processes. So here we have notations that are also used. When we were looking at the UML use case diagrams, I taught you the notations, I taught you the components and the symbols that are actually used. Then number 3, we have the flowchart technique. I'll talk about flowchart technique in details much later. So we are just trying to show the sequential flow and the control logic here of activities that are related. So we have different types of flowcharts. We have linear, we have cross-functional, we have top-down. I'll go into the details of that later. Then we also have data flow diagram technique. I'll also talk about data flow diagram in details later. I'm just introducing you to these techniques now. Then we have role activity diagrams, RAD, that are actually oriented on the role. They are modeling the role or the activities. They are somehow high-level views that normally capture the dynamics and even the role structure of an organization. Yes, we have Gantt charts again. Then we have the integrated definition for function modeling. I'll talk about them much later. We have gap analysis. I'll get into all those techniques much later in detail. I'll get into them much later or in detail. Okay, so I don't want to pump a lot of information. See, we are moving well. So far, so good. So I want to stop there. Then we're going to start from approach to use cases in object-oriented methods of information systems. We are going to talk about the concept of object orientation in the next class.